Welcome back. Here's another stats video on correlation. This one though, interpreting the correlation if we're given a score that represents it. Let's see what that's all about. Now the correlation between two variables can be represented with a number just as well as it can be represented on a graph. Now when we have a number assigned for showing the strength of correlation, we call it an R value or an R score. And an R score just means the correlation coefficient. These are fancy words that just means how strong is this correlation. Now remember from the graphs how I didn't care if my points were trending upwards or downwards on the graph? All I cared about was how close they were together. The same kind of idea applies when we have a number for correlation. I don't care if my number is positive or negative. All I'm looking for is how big that number is. Now numerically, correlation is considered to be perfect if it's either 1 or -1, and neither is better than the other. So 1 and -1 would represent perfectly placed dots on a scatter plot in a nice straight line. And as a number, as I approach 0, the correlation is getting weaker and weaker and weaker. On a graph, those would be points that are further and further and further apart. So let's look at this scale that really helps us understand what the R score means and how strong the correlation is as it approaches either 1 or -1, and how weak it is as it approaches 0. Now here are a couple of final exam questions that they might throw at you on this topic.
Hey, this is comparing correlation coefficients in numerical form, and the question is, which of the following values represents the strongest correlation coefficient? So once again, this is a question of strength. And I want to remind you that when we're dealing with strength, that we do not care about, it has nothing to do with, there's no equivalence with positivity or negativity. And that's the trap that you're going to see in this particular question here. So the easiest thing to do when we're dealing with looking for issues of strength is to disregard the positivity or the negativity of the correlation and just look for the number that is closest to 1. Now, you could also think of it as being closest to -1 if you don't want to lose those negatives. In other words, which one is the furthest away from 0 is another way of thinking about it. So when we look at these four numbers, we want to say, all right, well, which is the one that's going to be closest to 1 or -1? And so even though that -8 makes it seem like the smallest number, it's the one, if you ignore that negative, there you can see it as a decimal 8, or you could think of it as being closest to -1, depending on how you want to look at it. So this one right here is going to be our strongest correlation coefficient. The one that they want you to pick is the 0.7. This is the distractor over here, because they want you to think, wow, this is 0.7 is bigger than -0.8 because of the issue of the sign. But remember, strength has nothing to do with sign. So don't get fooled by this question over here. There's our answer right there in terms of the strongest one. The following question is, which of the following arrangements is a list of correlation coefficients ordered from strongest to weakest? So again, we're dealing with strength here. The format of this question is a little different because what they've presented us with is 4 arrangements of a series of correlations, and we want to see which one ranks them from the strongest to the weakest. So we want to make sure we know the difference between strong and weak, remembering that the strength of the correlation relates to how close it is to the number 1 or -1. So 1 or -1. And the weakest is going to be closest to 0. And remember, strength, again, has nothing to do with direction. So I usually look through these and ignore anything with a negative, and then I just kind of rank them from there. It's the easiest way is to ignore those negatives and rank them as you go. So as we go through the following distributions, if you take a look here we have a -0.7, and here we have a positive 0.9. This 0.9 is definitely stronger than that -0.7 because it's closer to the number 1 than it is to the number -1. Or if you just get rid of that negative, you can see that the 9 is bigger than the 7. And that's probably the easiest way to handle these questions all the way through. And when you do that, you're basically going to have to come through it until you find, here's the one that starts with 0.9. Now it looks great, but here we have a 0.6, and there's that 0.7. So again, when you ignore the sign, you can see that 0.7 is bigger than 0.6. So that's a trap. That's out of the equation. That's out of the equation. There's no way we're going to be starting with a negative 0.2. We know that negative 0.2 is a 0.2. And this is the one that's probably ranking it from weakest all the way to strongest. This is the trap question right here. This is going to be our answer right here. 0.9, negative 0.7, 0.6, negative 0.5, 0.3, and negative 0.2. Again, if you ignore those signs, if you just get rid of those, you can see that that's closest to the number 1, next closest to the number 1, and all the way down it goes until it approaches 0. And that's the easiest way to take a look at arranging correlation coefficients.